Hi, my name is Stephen Feuerstein. I'm the developer advocate for PL SQL at Oracle Corporation. I've been doing PL SQL since 1991, pretty much exclusively since 1994. My plan for today is to talk about dynamic SQL and some best practices. And then I'm going to turn it over to questions from you folks, and we'll look at different resources available online to learn more about dynamic SQL and PL SQL. Lots of ways to get information about resources on PL SQL from me and from others. Check out my YouTube channel, my blog post, subscribe to me on Twitter, follow me on Twitter, and of course, join us on Office Hours. What I want to do is help you develop and deepen your craft of writing excellent PL SQL code. Okay. So let's start out, as I said, with a quiz. What is wrong with this code? Here's a piece of code that takes an ID. Let's use my fancy pen. We pass in the ID. We get the name for the ID, and we return it. So the question is, what's wrong with this code? Dennis says, no bind variable. Good point, and we're definitely going to take a look at that. SQL injection risk from Roger Ford. Excellent. We're also going to take a look at that. No exception block from Eric. Always a good point. Every time you look at a piece of code, a stored program unit, you should ask yourself, why isn't there an exception handler? And it may make perfect sense, but it's always a good question to ask. All right, lots of good feedback. You know, it's funny because the one comment, I think the primary thing that I think is wrong with this code that I want to look at first has not been addressed. So here's my thinking about this piece of code. The biggest thing that's wrong with it is that the SQL in it is not dynamic. So what we're doing is concatenating in a bind variable. And we'll talk about binding versus concatenation. But the main thing is there's nothing dynamic about the select statement. So the first thing I want to talk about with dynamic SQL is that we should only use it when necessary. So why would you want to use dynamic SQL? First of all, you want to use it because the SQL statement fundamentally cannot be parsed at compile time. So at the time you're writing your code and pressing the compile button in SQL Developer or whatever you're using, you're missing some information that is needed to actually parse the SQL statement. In other words, you're not missing the bind variable value. That's something separate, and we'll talk about that. But for example, the table name might be dynamic. The structure of the SQL statement might be dynamic. There's something that has to be resolved at runtime versus compile time. Another example of this might be that database objects that you need to use are created just in time inside your code. So for example, you use dynamic SQL to execute immediate and create a new table, and then you have an insert into the table afterwards. Well, your insert statement has to be dynamic because the table might not be present until you run that program. That's probably a fairly uncommon scenario, but it's one of those cases. And I think the third situation that can be a compelling argument for dynamic SQL is that even if you could write it all in static SQL, you end up with lots of code repetition, minor variations on the SQL statement, and you could greatly consolidate your code, make it easier to maintain by making it dynamic. And I think the argument for taking that approach, in other words, code reduction, improved code maintainability, by moving to dynamic SQL is usually something you would justify for administrative processes and scripture writing, not so much your production code. But it's certainly a good use case for dynamic SQL. Let's keep going. So one of the most important things to remember with dynamic SQL, assuming you actually need to use it, is you should almost always, whenever possible, bind variable values into your SQL statement, not using concatenation. Here, for example, I've got an ID coming in, and I'm concatenating the value to the string. I'm creating that single long string, and then I'm executing it with the execute immediate statement, which is a part of native dynamic SQL. What's wrong with that? Well, if you're concatenating values into the string, then you're essentially passing, and let's say I have 10 or 100 different values coming in, 1 and 2 and -1 and 100. Those become different SQL statements, physically different SQL statements when they're passed over to the SQL engine for processing. And that can result in additional hard parsing, unnecessary hard parsing, which will slow down your processing. So by going to binding, you're essentially passing the same SQL statement. The only thing that's changing from execution to execution is the value and you're using a bind variable, then the SQL statement looks like ID equals colon B1 for all the different executions. Therefore, it's parsed once, and you get better performance, and you reduce the opportunities for SQL injection, which has to come in through concatenation. Note, however, that you cannot bind the values, the names of tables and columns or entire chunks like where clauses of the SQL text. The way to remember it is that the PL SQL engine has to be able to parse the statement, really the SQL engine. Not sure why I wrote PL SQL. Maybe because my fingers are just stuck on writing PL/ all the time. So the SQL statement at compile time, the SQL engine at compile time, has to be able to parse the statement. It has to know the name of the table so it can resolve the references to the columns. It has to know the column names so it can make sure they're valid columns for that SQL statement. And you can't do that if you're binding those values in. So you can't bind names of tables and columns. You can only bind values, variable values, which is the whole point. Okay, so let's take a look at this code. So now this is a rewrite, a little tiny rewrite of that same piece of code. Let's take a closer look. So I'm still passing the ID. Now I'm passing in the table name. Now you could argue that this is not a good idea, and we're going to explore that more in a little bit. But now we can at least realize that that dynamic SQL is needed. Since I have different table names coming in, then I could do a non-dynamic approach of saying, if table name equals X, select from X. If table name equals Y, select from Y. I could even use a cursor variable. That will do that for me. It's still with static SQL. But if it's truly dynamic and you're not sure how many different tables might be passed in, okay. So I concatenate the table name in. And then I bind the variable value through a placeholder. So inside my statement, I now say this is all one string. One string. And it's getting confusing, so let's erase that. So this is all one long string. And now I have a colon to indicate that this is a placeholder. And it could be colon 1, 2, 3. It can be numbers or strings. And then I get my value back with the into clause. And then I add the using clause to specify that this value, the value of IDN or that expression, should be associated with or replace the placeholder at the time of execution. So you can see here now that this statement will be the same, physically the same, regardless of how many different values are bound in. So I get that single hard parse, and then I avoid the possibility, in addition, of SQL injection through that concatenation, though I could still have it here. Then I return the name. So there's an example of a quick conversion, essentially, from concatenating the variable value to moving to a placeholder and actually needing dynamic SQL because of my dynamic table names. So what's wrong with this code? I think I pretty much already mentioned all of it, so I'll just keep on going, and then we'll get into the conversation discussion in a bit. So what's the problem with this code? The biggest problem with this code right now is that I'm concatenating in my table name. And you might say, well, what's the big deal? I concatenate in the table name, and off you go. And if it's not a valid table name, well, then it won't find any values. It'll raise an error, and we're good. The problem is that whenever you're concatenating in a SQL statement, you can end up with SQL injection issues, which means that you might think that, well, you're just going to pass in a table name. If it's a bad table name, nothing bad will happen. But if this value, if this name of this table is being passed in directly from an external field, for example, on a screen, and users have the opportunity to type in anything they want, things can get a little bit crazy because they can inject unintended code into that SQL statement that makes it do things that you might not have expected or wanted it to do. For example, my table in could have a semicolon and then start to execute other commands, which is more relevant in dynamic PL SQL. It could also say from all users, for example, a data dictionary view, and then union all, and then start to do something else. So things that seem obviously safe to you at a glance could be very unsafe when you have clever people on the outside sending text in that you're not checking for properly. So if you're going to do concatenations, which is often the case for dynamic SQL and dynamic PL SQL blocks, here are some important things to keep in mind. First of all, user input should never, ever be fed directly into your dynamic SQL statement. In other words, if there's a field on the screen and somebody's typing in a value that can then be passed in to be used as part of a SQL statement, it should never be taken directly from user input and stuck into that string without you doing some checking and processing first. So, for example, if it could be a table name, you'd want to have them select a list of tables off the screen, though it's unlikely you're going to give them access to a list of tables as well. But the bottom line is, unfiltered user input into SQL statements is a bad idea. It should never be allowed. That's the primary attack vector for SQL injection. If you are concatenating in the names of tables, the names of schemas, etc., into your statement, which I showed you in the example just before, you can use a package called DBMS assert to check to see that those names are valid names inside the database. It'll do that checking for you, and much more comprehensively than you'll be able to. And I'll show you an example in just a moment. And you could even do some whitelisting or blacklisting of that text coming in. So you could say, you know what? We'll let them type in whatever they want, and we'll bring it into our code, and we'll put it into a SQL statement. We'll construct a SQL statement around that. But we're never going to allow a semicolon. That should never be in their input. We're never going to allow X and Y and Z. So to look at a very simple example of adding a little bit of protection to this name from ID function, take a look at this. So now I'm passing my table name, the ID, and a whole big fat where clause. Oh, that's so cool. That's so generic and scary. So execute immediate. I'm going to construct my SQL statement, select the name from the table. Now notice, instead of just concatenating in the table, I'm calling DBMS assert qualified SQL name. And this will make sure that the value that's being passed in is a valid SQL name, schema.table, schema.view, etc. I'm binding in the ID. And here's my little blacklisting on characters. I'm saying, yeah, you can pass in your where clause, but you know what? If it's got a semicolon, or if it's got a vertical bar, for example, doing additional concatenations, I'm going to replace those with null. I'm going to get rid of them. And if it works when we're done, great. If it doesn't work, that's your problem. Of course, this is a very crude approach to take. You might want to actually not even get this far, so that even above your code, before you execute immediate, you would check to see if the where clause has certain characters in it. And if it does, simply raise an error. Don't allow it to even execute. Lots of different approaches you can take. The main thing is never allow strings like this to come directly from the user and then directly into your SQL statement without interference, without running interference. So what I'm going to do is keep on going through a little bit more, and then we're going to take a look at some live SQL scripts on dynamic SQL and so forth, some resources online. So some other dynamic SQL good to knows. First of all, I've only shown you, and I haven't really gone into any detail, I've shown you the execute immediate syntax. That's called native dynamic SQL. It's built into the PL SQL language itself. Prior to native dynamic SQL, which is added in, I think it was Oracle 8i, Oracle 8 maybe, quite a long time ago, the only way you could do dynamic SQL was with DBMS SQL, which is a very powerful dynamic SQL package. But you really don't need to use it except for the most extreme cases, essentially method 4 dynamic SQL, in which at the time of compilation, you don't know how many variables you're binding in, or you don't know the number of columns in the select list you're getting back, which makes it difficult to write using an int clauses because those are static clauses in your PL SQL code. So don't use DBMS SQL if you can use execute immediate, is what it comes down to. And there are a vanishingly small number of use cases where DBMS SQL can come in handy. Execute immediate, in terms of using execute immediate, don't do what I did here. So this is just a simple example. And what I did was construct my SQL statement right in line to the execution of the statement, right inside the execute immediate. Now, the problem here is that if something goes wrong with the statement execution, and it could most likely it will be a problem with my construction. I forgot to put a space around my and statement, my and keywords, and so on. There are many ways we can mess up constructing these complex pieces of dynamic SQL. So if I have a problem like that, I get an error. It says, invalid statement or whatever the error might be, but I don't see what was just glommed together in my code. So the suggestion is to always assign this to a variable first. Execute immediate the variable. And then in your exception handler, you can log that variable value, the query or the statement. And then when you do your diagnostics and your analysis of the error log, you can then see, oh, I've got it all smushed together. I didn't put spaces between each keyword and so on, right? So execute immediate a variable so that it's easier to log the error and figure out what went wrong. Now, also remember that when you execute a dynamic DDL statement, execute immediate, create table XYZ, the only way you can do that is in dynamic SQL. You can't use static SQL for DDL statements. Remember that when you execute a dynamic DDL statement, the database will automatically commit before and after that statement. So it'll commit whatever changes were outstanding. It will then attempt to execute the DDL statement. If the DDL statement succeeds, it will then commit after that. So what you might often want to do is, if you're executing dynamic DDL, is put it inside its own little autonomous transaction procedure. In fact, let's take a look at that. I'm going to go over to SQL Developer and pull up one of my favorite programs ever, Drop Whatever. Excellent utility that your database, your DBA would love to install in the schema for you. So basically it says, you know what, I want to make it easy for you to drop things. So you specify the name and we'll wildcard it. You specify the type and we'll wildcard it. And then I'll go out to the user objects data dictionary and find all the matches of objects that match the filters. And then I'm going to drop them. So here you see that I've got a separate string, a variable, that I'm going to populate with my drop statement. And then I'm going to execute immediate the statement. If something goes wrong, I can log, or in this case, display the statement, check out the format error stack and so on, and go on to the next one. Obviously, you really don't want to use a drop whatever program. It's a little bit too powerful, except maybe in your dev environment. But the key points here are, I've got my variable, I execute that, and then I can log that statement. In addition, it's an autonomous transaction pragma, which means that the commit that occurs, but when this execute immediate happens both before and after, only saves the changes in this program. So if there are outstanding uncommitted changes in my session before this program is called, they would still be uncommitted. Now, you may or may not want that, but usually with dynamic DDL, you want to isolate the effect of that commit. Okay, so before I get into some questions or a question or a comment that came in, I'd like to go over to my friendly neighborhood browser and just show you a couple of resources that will help you in terms of exploring dynamic SQL further. First of all, on the PL SQL Office Hours page for this session, if you scroll down to the resources at the bottom, you'll see a couple of links to both documentation, YouTube videos, and also Live SQL, dynamic SQL scripts. Live SQL offers 24/7 access to the Oracle database. So I'm going to sign in. I'm going to search for dynamic SQL. And you'll find lots and lots of dynamic SQL scripts, most of them for me, fortunately not all of them, but this will allow you to explore in much greater detail than we're going to do on the call today. Issues like different methods of dynamic SQL, methods 1, 2, 3, and 4, using DVMS assert. So here's a script actually I put up yesterday that runs through some of the different features of the DVMS assert program. So for example, I want to assert that the value passed in is a valid schema. And you call the function, and it returns the same name that you passed in if it's a valid schema. If not, which we got down here, this is an invalid schema, it tells you, invalid schema. I can also ask it if it's a valid qualified SQL name. And here's an example of, is it a SQL object name? So I'm going to pass in this string. Here's an example of an attempt to inject. So it's, let's say my statement said select XYZ from and then concatenating the table name. Well, somebody very clever said, oh, I'm going to give you a table name, but then comma, and then I'm going to do a select star from all users, and I'm going to get a Cartesian product that will show me all the names of the users in your database, which I can then use to go fishing, contacting those people somehow, or even getting more information from the database. So DBMS assert says, no, that's not a valid object name, and it rejects it. So my point here, because I'm not going to spend the whole session going through all these different scripts, is that you've got a lot of resources on Live SQL, just search, and dynamic PL SQL as well for examples. So search out those and go exploring. And then in addition, if you're not familiar with the DevGym, we have a website called the DevGym, devgym.oracle.com, that offers quizzes and workouts and classes on SQL and PL SQL. So let's say you want to get better at dynamic SQL. You can go to workouts, click on do-it-yourself workout. And then you can construct your own workout. So for example, I'm interested in a PL SQL workout. I'm going to choose dynamic SQL. I'd like to do an hour workout and any difficulty, add to my workouts. And we go out to our quiz library, and there's something like 1,600 PL SQL quizzes that I've built up over the last 8 years. And now it's created this workout for me. And I can now go into each one of these different quizzes and strengthen my understanding, reinforce my knowledge about dynamic SQL. And the basic idea in the DevGym is you read code. You actually sit here and read code. Though you could, since it's not competitive, you can grab the code and run it yourself if you want to. But the main idea is to strengthen your code reading skills. You read the code and you decide which of these choices are correct. And so I can just go through each of my quizzes and really reinforce the knowledge that you get out of this session or any particular topic area in PL SQL that we've got quizzes for, which are a lot. So we've got a lot of online resources in AskTOM, in Office Hours, in Live SQL, in the DevGym to help you with dynamic SQL and many other topics. When I said, what's wrong with this code? And we talked about possible SQL injection issues here, then Nils said, what's the real SQL injection issue here? This is the parameters declared as an integer. And that's a really good point. So really the issue with SQL injection comes around with string management. So for example, if you're executing SQL from JDBC, from JavaScript and so on, you're pretty much always doing dynamic SQL. You're constructing these big strings and passing them to the SQL engine. And that's where you run into problems with SQL injection. When you're passing in an integer or a date or a Boolean, and there are actually ways to work with Booleans in dynamic SQL or dynamic PL SQL, starting in 12.2, then you don't have an issue. So Nils, good point. Here we don't really have much of a SQL injection issue because it's an integer. Excellent point. And Sven Weller says that his favorite table name is dual, semicolon. Let's actually put this into SQL Developer. So what Sven was talking about is that his table name, if he was calling a program, execute my proc table name, his favorite table name is dual. Drop database. Yes. As many of you may know, have you heard of the Bobby Tables SQL injection cartoon from XKCD? What you think is a lockdown statement, like I say where, concatenated in a string, and then group by or order by, it looks like nothing can fit there except a where clause. You can have all sorts of fun by injecting semicolons, by injecting union all, et cetera, et cetera. So watch out for that stuff. Okay. Isn't SQL object name better than qualified SQL name? Yes. So I think I showed you examples of both of these usages. In Live SQL, you see in the Live SQL script, you saw the SQL object name. This is basically making sure that it's a qualified SQL name, x.y.z, as opposed to actually checking to see if the object name itself is valid. So take a look at the DBMS assert package description, documentation, and make sure you understand the different built-ins and what they do for you. I need to bring data in from 4 different tables, each have interval partitions, and I need the latest interval partition data. I've seen in AskTOM Answers that we need dynamic SQL to get the latest partition. Can you please explain? And the answer is, I can't really explain that very well because I haven't worked with partition tables very much, and certainly using dynamic SQL to do it. So I suggest that you go to the SQL Office Hours session that Chris will be doing, I think later this week or next week, and explore that topic with him. Cruising on along. There's a question about dynamic SQL. Is it good to use in terms of performance of the database? So let's take a break from sharing my screen. A long time ago, let's say back in Oracle 7, Oracle 8, etc., dynamic SQL had a pretty significant overhead to it, which is another reason that you'd only use it when you absolutely had to. Certainly in the days when DBMS SQL was the only mechanism for doing it, That's a very heavy-duty PL/SQL-based API to execute your dynamic SQL statements. And even execute immediate, when it was first introduced, was not terribly performant. And I'm just turning off a couple of your videos that are showing up because you don't really want to be a part of my show, right? So if you don't mind, turn off your video. Okay. So in the old days, the overhead of dynamic SQL was significant, was noticeable. These days, simply taking a select statement or an update statement or whatever it is, and putting it inside an execute immediate framework is not likely to cause a significant overhead. Certainly, if you've got a large SQL statement that involves a fair amount of parsing, for example, that will overwhelm the overhead of actually running it through the execute immediate or dynamic SQL engine. So I don't think that using dynamic SQL should raise a performance issue in and of itself. If you're concatenating variables instead of binding them and introducing repetitive, hard parsing of cursors when they're not necessary, that's the sort of thing that can make it look like your dynamic SQL is slow, but it probably has more to do with how you're using dynamic SQL rather than the dynamic SQL engine itself. I know that the objective of the development team, several years ago I heard this, was at some point to make dynamic SQL and static SQL essentially equivalent from a performance standpoint. I don't think that's true yet, but it's pretty close. What would be the best practice on the exception block? Exception handler. So let's take a look at a piece of code. Let's go back to, let's share my screen. Let's go back to SQL Developer. So here's my drop whatever function procedure. And again, I made sure that my variable, my dynamic statement was assigned to a variable. And then I tracked the exception that occurred so I can log the error. Now, of course, I'm not logging the error here. I'm just outputting with dbms_output.putline. So this is not a best practice for an exception handler. Hopefully some of you use the logger package. Basically what you should have is a generic logging utility that you always have available to you, so that you can simply say something like log error, and then text in, let's say, drop string. And then re-raise if you choose to re-raise. So essentially you should have some version of a logging error procedure that hides all the details like get the format call stack, get the error stack, get the backtrace, whether you're using the built-ins and DBMS utilities or the util call stack package. All of that is inside this simple procedure. And what you want to pass into this procedure is any of this, the application-specific context that you would otherwise lose. And in fact, what it would normally be, or the way my code usually looks like, is this. So what did I call? That's the overall context. What are the values that I'm grabbing from this local context? And the reason I like to make sure I grab this information is that once this exception, once I either re-raise or allow it to continue, usually if we re-raise out of this and we have, let's say, another program up here, an outer block, and I say exception and others, then log error, inside this outer block, this information is gone. That was a local variable in that context. When the exception bubbles to the outer blocks, it loses the local context. So my approach, my best practice for handling exceptions is I handle in the block itself where the error could occur. I log any specific values in the state of that block of code. Then I propagate the exception out. Besides that, I don't think there are specific error handling requirements for dynamic SQL or dynamic PL SQL. Going back to my chat line. Do we have a package check syntax of dynamic query before run? Do we have a package check syntax? So is there some sort of utility that you can run to check the syntax of your dynamic SQL statement before it's run? Well, I like the idea, but I really don't see how it could work because, of course, the whole point behind the dynamic SQL is that only at runtime do you actually construct the SQL statement. So there's not a lot of you can do about that. Another thing that I will do, though, and you see this in the drop whatever, is I build in essentially test-only mode. in this case, just checking. I do this in a lot of my programs, whether they have dynamic SQL or not. So with my just checking, or usually it's test only m, and I might even pass some override test values, test parameters as well. So if I'm only testing, then I'm just going to display the string. If I'm really doing it, I'm going to run it. So if you've got some really crazy dynamic SQL and you're really not sure how it's all coming together, you could just run it in dev, obviously, and see what happens. And when you get the error, take a look at your SQL statement. But you can also give yourself a little bit more flexibility by building in your test-only mode, and then just looking at the string. And you can even grab the string at that point and then try to compile it or try to run it yourself in your local development environment. So that has been handy for me. How much PL SQL support is enabled or available in a sharded database versus a normal relational database? Well, as far as I know, I haven't worked with sharding yet, but as far as I know, there's no difference with PL SQL. It's sort of like, what's the difference with PL SQL in the cloud versus on premises? Well, there's no difference. PL SQL is inside the database. There may be different packages like DBMS Cloud that you can execute via your PL SQL blocks and otherwise to execute cloud-related behavior. But by default, PL SQL is PL SQL, which is why the book that I wrote in 1994, I'll do a little advertisement. Why the big fat book I wrote in 1994 is still largely relevant and unchanged. 14 years later, love it. How can we run multiple dynamic statements in parallel? Well, PL SQL is not a multi-threaded language. There is a package called DBMS Parallel Execute. It was introduced in 11G, and it allows you to define SQL statements which will be executed, pardon me once again, dynamically. So here's an example of here's my statement. I create a task, and I associate that task with the statement. I can define the chunks by which I want to parallel execute. So in this case, is by row ID. And then I execute the statement, and I specify the parallel level. So this may handle some of what you want to do. But in general, if you want to run multiple jobs at the same time, you can use DBMS Scheduler. So for example, I've just been doing this with the Dev Gym. We've been doing a lot of upgrades to the gamification, adding trophies and calculating your progress towards getting trophies. We've actually been doing some fixes to some of our original updates. We had to run some fixed programs and initialize trophies. So what I've got here is a call to my initialize player trophies program. It takes a user ID range, start and end. And then I use DBMS Scheduler to create a job to run immediately. So I construct the block of code, I execute the dynamic PL SQL block through the job. There's no frequency. It's not running every day or every hour. I actually set up for these to run simultaneously. So that will give you some element of parallel execution via the DBMS job scheduler. The main disadvantage of dynamic SQL in my memory is that it's unpredictable when it comes to performance and query plans. Well, Dennis, I suppose it might be true. We'd have to look at specifics, but I don't see why that would be the case. When you're executing your statement dynamically, you're still, from the SQL engine side, it's the same. It ends up going to the SQL engine doesn't do dynamic SQL. Dynamic SQL is PL SQL putting things together at runtime. So it's odd to me that simply shifting from static to dynamic SQL would result in unpredictability, except in the sense that your SQL statement could change. If your SQL statement changes enough, different tables, different where clause conditions, obviously that could change the explain plan. That could change the performance. But I don't think the issue there is dynamic SQL. The issue there is that you've got a variety of SQL statements that need to be optimized properly. So I'm not sure that you'd want to blame that on dynamic SQL, but you can if you want to. We use dynamic SQL a lot for ETL, extract, transform, and load. So hard parses is less of an issue. And I don't think much about SQL injection, right, since it's all driven by your code. For a lot of us, SQL injection is not really much of an issue. Certainly, if you take Bryn Llewellyn's SmartDB approach of building a hard shell around all of your SQL with a PL SQL API, his argument would be, you never do dynamic SQL at all. It's not an issue. I think in the real world, we tend to run into a number of dynamic SQL scenarios, but even again, looking at this program, get me the current comp events. Nothing is coming in here in terms of a chunk of SQL text. So I've got a dynamic SQL statement because of my variations, but I'm completely controlling the construction of that statement. So again, there's no SQL injection concern here. And I think that will be true for a lot of your situations. That's the thing to check. If you're ever doing an execute immediate or DBMS SQL operation, you should trace through where that string comes from. And if it comes directly from a user input with nothing in between, that's a problem. That's where you need to step in and make sure DBMS assert is in place, put in all sorts of checks and restrictions. But usually it's all internalized, and we have to worry less about SQL injection.